Math 8, Unit 2 Transformations, Lesson 3, Part 1. Introduction to Reflections. Okay, here's a couple pictures that show reflections. This is a concept that you should be familiar with. Pretty much everyone's looked in a mirror before. So, here we have a child looking in a mirror, and I want you to notice that the child's right ear appears to be a left ear in the mirror. It appears to be. It's still the right ear, it's just appearing as though it's been reversed. Alright. One misconception about mirrors is that they reverse left and right when you look into them. And if that were true, when you raise your right hand, the person in the mirror would also raise their right hand, but it appears they're raising their left. It actually doesn't reverse left and right. It actually reverses away from the mirror with into the mirror. So, otherwise, if it didn't reverse away and into, you would look into the mirror and see the back of your head. Now, that would be helpful if maybe you were trying to style your hair, but most cases it wouldn't be very helpful. So a mirror does not technically reverse left and right. It reverses away and into. And you can see that on the lake here. It reverses up and down. So whatever the surface of the mirror is, what gets reversed is coming straight out of the mirror and straight into the mirror. So here's this is how a mirror ends up working. When you look at a mirror, you are looking at the top of your head, but according to what you see on the mirror, it's a little bit below where the actual top of your head is. And if the mirror is large enough that you can look down straight at your feet, it will appear, the size of your image will be within this range, but it will appear larger because it appears as though it is behind the mirror. This is what's called a virtual image. When you're looking in a mirror, you end up looking at a virtual image, which is created just by light rays bouncing around. Now, I do want you to watch a video about mirrors put together by Vsauce. That will be after this video. But first, in your notebook, I can recognize, describe, and perform reflections. Notice that a reflection or flip is a transformation in which a figure is reflected in a line called the line of reflection. A reflection creates a mirror image of the original figure. So I can recognize, describe, and perform reflections. Also in your notes write, a reflection requires a line to reflect across, and the image appears on the opposite side of the line of reflection. You will want to pause the video and take some time to copy this down. Okay, let's look at some examples. Tell whether the blue figure is a reflection of the red figure. So since it's of the red figure is the pre-image, and the blue figure is the image here. Not that that matters too much right here. So on A, does that appear to be a reflection? I would say yes, it does. Every point is the same distance from the line of reflection, just on the opposite side. Every point is reflected across the line of reflection, so that its reflected point is as far to the other side of the line as the original point was from the line. Okay, B, is that a reflection? Nope, not this one. That kind of looks like what it would be if you were looking at the back of your head. You don't look into a mirror and see the back of your head. You would see it looking back at you. So it'd be more like that. Okay, tell whether the blue figure is a reflection of the red figure. On these we're going to explain. So A, is that a reflection? No, it is not. And the reason is it is not flipped. It's just a translation. Translation, remember that's a slide. Is number 2 a reflection? Well, that one also, no, because it is a translation. Okay, let's look at 3. Does 3 show a reflection? Well, if we look at this, everything looks like it's, if you fold it in half, you get everything to line up. So yeah, that is a reflection because, how would I say this? Well, it's got the symmetry, right? If I were to cut it out and fold along this dotted line, I could get those two congruent shapes to line up exactly, which is what reflections would require. It's that symmetry, line symmetry.